This is the Chapter 6 review, and as always, I am the amazing Mr. Jansen. That's where we go. If we look at this first one, the first thing we have to do is raise all this to the second power. 4 to the second power is 16. When I raise something to a power, I multiply the exponents. So that's going to be an a to the fourth and a b to the negative sixth. And now I can multiply by the second piece. So that gives me a 32. When I multiply, I add the exponents. And now I have to take care of negative exponents, which means this thing translates into a 32 a to the ninth over b to the fourth. For the second one, this entire thing is being raised to the 0 power. Remember, anything to the 0 power is 1, so this entire thing just equals 1. And that's it. For this one, I would start inside the parentheses and do the division. So here, that gives me a negative 2. When I divide, I subtract the exponent. So 3 minus a negative 5 is x to the 8th, y to the 5th. And then here's z to the negative 6 divided by z to the first. You subtract the exponents. Negative 6 minus 1 is a z to the negative 7th. And now I'll raise everything to the fourth power. Negative 2 to the fourth power is 16. I multiply the exponents. So that's a 32, y to the 20th, and a z to the negative 28th. And now, of course, once again, I take care of negative exponents. That's going to be a 16x to the 32nd, y to the 20th, all over z to the 28th. Number 4 is very similar, except there's nothing that we can divide inside of here, so I'm going to go right to doing the exponent. So 3 to the third power is a 27. I multiply the exponents. That's a c to the negative 6th, d to the third. Underneath here, 4 to the third power is 64. I multiply the exponents. That's a z to the 15th. And now the last thing I do is take care of the negative exponents. Keep in mind, this 27 is not associated with that c to the negative 6th. The c to the negative 6 stands alone, so that's the only thing that's going to get sent to my denominator. That's it. For the next one, we're adding and subtracting. We're essentially just combining like terms. So for this one, the 3x to the third doesn't have a like term, so it stays as a 3x to the third. The 2x squared also does not have a like term, stays as a 2x squared. But then the minus 4x and the positive 5x is a plus 1x. The 5 and the negative 8 gives me a negative 3. And now I've combined all the like terms, so that's it. When you're subtracting, I would recommend changing this to adding the opposite. And now I'm just once again combining like terms. The 3x squared and the negative 2x squared is an x squared. The 4x and the negative 5x is a negative x. And then the negative 7 and the positive 9 is a positive 2. Number 7, I just want to use my distributive property to simplify this. So I'm distributing this value. So I multiply, that's a 6. I add the exponents, x to the fourth, a minus 9x cubed, and a minus 3x squared. Number 8, I have to distribute twice. I have to distribute here the 2x, and then here I have to distribute the negative 4. So that's going to give me a 2x squared minus 4x. Here I get a negative 8x and a minus 16, and then I just combine like terms. For this one, I'm multiplying, and you can distribute backwards if that's more comfortable. I distribute the x. It's going to give me a 2x cubed minus x squared minus a 6x. And now I do the same thing with the negative 2. I distribute the negative 2 to each of these, which is going to give me a minus 4x squared plus 2x plus 12. And then I once again combine like terms. For number 10, our temptation is just to square each of these things, but keep in mind a 2x minus 3 squared means a 2x minus 3 times a 2x minus 3, which means I have to use my distributive property. So I distribute the 2x, that's a 4x squared minus 6x. Then I distribute the negative 3 and get a negative 6x plus 9. So then when I combine the like terms, and if I try to do a little bit of a shortcut there, I'm going to end up missing out on my middle term. For this one, I want to factor it completely. So to factor this thing completely, 4 terms should be a giveaway for factoring by grouping. So I group the first 2 terms together, the second 2 together. That leaves me with an x squared to factor out, which then I'm going to have a 2x plus 1. Out of the second 2 terms, I can factor out a negative 4, which leaves me with an x plus 1. Sorry, a 2x plus 1. So now my 2 factors are the 2x plus 1 and the x squared minus 4. But of course, an x squared minus 4 is a difference of squares, so I have to factor this thing a little bit further. Factors into an x plus 2 and x minus 2. Number 12, this one is quadratic in form. I have something squared, something to the first, and a constant term. So when I do this, I build a bridge just like I normally would, a negative 18. The 2 numbers are a negative 6 and a positive 3. And normally, if this was just an x squared, let's think of it this way. If this was an x squared minus 3x minus 18, it would factor into an x minus 6 and an x plus 3. But since it's not an x squared, it's an x to the 8th, I don't need an x times an x. I need an x to the 4th minus 6 and an x to the 4th plus 3. And that's how I factor something that's quadratic in form. I do the same thing, but I make sure that my terms match up to give me the x to the 8th and then to give me that middle term of x to the 4th. In this one, I factor out the greatest common factor. That's a 2x squared, which leaves me with an x cubed plus 27. And now from here, x cubed plus 27, that is a difference of squares. So this guy's just going to tag along for the ride. The difference of squares factors into a binomial and a trinomial. Let me give myself a little bit more space here. And now I use SOAP, the same opposite, always a plus, so this sign was a plus. So this sign is the same, this one's the opposite, this one's always a plus. The cube root of x cubed is x, the cube root of 27 is a 3. And then x squared is x squared, 3 squared is 9. The middle term, I do the x times the 3, which is a 3x. And that's how I factor a sum or difference of cubes. And the next one I want to solve, and I want to do this by factoring essentially. So the first thing I notice is that there's 4 terms, so I'm going to do by factoring by grouping. Out of the first 2 terms, I can factor out an x cubed, which leaves me with an x minus 1. Out of the second 2 terms, I can factor out an 8, which leaves me with an x minus 1. So now my factors are the x minus 1 and the x cubed plus 8. And this whole thing set equal to 0. And now the x cubed plus 8, this thing is a sum of cubes. And so since this is a sum of cubes, I'm going to go ahead and factor it into a binomial and a trinomial. This guy, it stays the way it is, the x minus 1. So a binomial and a trinomial. This sign is the same. This one's the opposite. This one's always a plus. So that's going to be an x and a 2. I'm taking the cube root. X squared is an x squared. 2 squared is a 4. 2 times ax is the 2x. Okay? And now I have this thing factored completely. I said each factor equals 0. Here I get x equals 1. Here I get x equals a negative 2. For this last one, I'm going to solve this by completing the square. So I would probably subtract the 4 from each side. And I do b divided by 2 and square it, which is a plus 1. So that leaves me with an x minus 1 squared equals a negative 3. I take the square root of each side. So when I do that, let me bring it up here. That's going to be an x minus 1 equals plus or minus I root 3. And then I can add the 1 to each side. So I find out that x equals a 1 plus or minus I root 3. So these are my 4 answers. The 1, the negative 1, and then the 1 plus or minus I root 3 accounts for 2 more of my answers. That's it. If I look at number 15 is quadratic in form. something squared, something to the first, and then a constant term, so I build a bridge. Two numbers that multiply together to give me a 4 but add to a -5 are a -4 and a -1, which means this thing is going to factor, instead of an x minus 4 and an x minus 1, this has to be an x squared minus 4 and an x squared minus 1. And now each of these is a difference of squares. That's an x plus 2 and an x minus 2. The x squared minus 1 is an x plus 1 and an x minus 1. And I set each factor equals 0. So I get x equals a -2 and a +2, so plus or minus 2. Over here, I get a +1 and a -1, so plus or minus 1. And that accounts for all 4 of my solutions. Okay? For the next one, I want to divide either with long division or synthetic division. This one, I can't use synthetic division because there's a squared term out front. So I'm just going to put this out front. I'm going to set it up as long division, so I've got a w squared. I'm missing a term here, so I'm going to put a 0w in its place. And really, that just helps me keep everything in the proper order and line up my like terms. So now that's a 3w cubed. That is an ugly-looking cube. Let me try again. Plus 7w squared minus 4w plus 3. And now I just ask myself, w squared times what will give me the 3w cubed? And that's going to be a 3w. So now I multiplied by this trinomial, so I'm essentially doing my distributive property right here. That's going to give me a 3w cubed plus 0w squared plus 9w. And now I'm going to subtract, and my recommendation is to change subtracting to adding the opposite. So when I do that, that gives me a 7w squared minus 13w, and then I bring down the next term, which is the plus 3. Now I start over. A w squared times what will give me a 7w squared, and that's going to be a 7w, or sorry, just a 7. So now I take the 7 times what's out front. That's a 7w squared plus 0w plus 21. And now I subtract, which is the same as adding the opposite. So that's going to leave me with a negative 13w minus 18. And I can't turn a w squared into a 13w, so that's my remainder. So I put a plus sign here. I write the negative 13w minus 18 over the thing I was dividing by, which is the w squared plus 3. That's it. For the next one, the only thing that makes this a little bit tricky is, one, interpreting this negative exponent. Remember, a negative exponent just means I'm going to send this thing to the denominator. So I would rewrite it like this. Okay, that's what the negative exponent does. It just sends it to the denominator. So I just have a big division problem here. So I've got the y squared plus 2y minus 1. And I'm dividing that into, well, this thing's missing a lot of terms here. That's a 6y to the 4th. I'm missing the y cubed. I'm missing the y squared. I'm missing the y to the 1st. And then I have the minus 6. So I put zeros in for all these missing terms. And I start this process. Y squared times what gives me the 6y to the 4th is a 6y squared. I multiply that by what's out front. Essentially, it's my distributive property. That's a 6y to the 4th plus 12y cubed minus 6y squared. And now I'm going to subtract, which once again I would rewrite as adding the opposite. When I do that, it gives me a negative 12y cubed plus 6y squared. And I would just bring down the next term, the 0y. Now I start the process over. Y squared times what gives me a negative 12y cubed. It's going to be a minus 12y. And now I multiply by what's out front. That's a negative 12y cubed minus 24y squared plus 12y. And now I'm going to subtract, which is the same as adding the opposite. When I do that, that gives me a 30y squared and a minus 12y. And then I bring down the last term, which is the negative 6, and I start the process over. I've got to multiply by a 30 here. So I multiply, that's a 30y squared plus 60y minus 30. And I'm going to subtract, which once again is the same as adding the opposite, which is going to give me a negative 72y plus 24. And I can't go any further, so that's my remainder. So I put the plus sign. I've got a negative 72y plus 24. And I put it over the thing I was dividing by, which is the y squared plus 2y minus 1. And that's really ugly. Let me try writing that again. That's it.